Problem 2 from chapter 21. We are given a certain light bulb is rated at 60 watts, operating at RMS voltage of 120 volts. So 60 watts is our power, 120 volts. And then we have a peak voltage. No, we're asked, what is the peak voltage applied across the bulb? So find peak. And then that's part A. And then part B, it says, what is the resistance of the bulb? So find the resistance. Part C, does a 100 watt bulb have greater or less resistance than a 60 watt bulb? So we want to compare resistance of a 100 watt bulb versus resistance of a 60 watt bulb. Okay, for part A, we're told that the RMS voltage, I don't know why I wrote this down, it's actually VRMS, that's what we're told. VRMS voltage is 120 volts. And so we can just apply this handy formula that we have. Max is square root of 2, V max over square root of 2, right? So then we want that, we take square root of 2 times V RMS, we get V max. That's going to equal 170 volts. Okay, fairly straightforward. So now we're told the power, P is equal to 60 watts, and we want to find the resistance of the bulb. Now let's recall that power is equal to I squared times R. We don't know the current, but it's also equal to, let's say, V squared over R. And this would be RMS, right? So then we can just find this by rearranging a little. So we can take R to the other side and square root it. Sorry, we're not solving for V, we're solving for R. So we take R to the other side, take P down here, and then we get RMS, VRMS squared over P is equal to 120 volts squared over 60 watts. That's going to give us a value of 240 ohms. Okay. Part C, we are asked to compare the resistance of a 100 watt bulb versus a 60 watt bulb. And we're assuming that the RMS voltage is going to be the same. So, let's say now we know what the formula for resistance is, so let's use that. So let's say here's R, we'll call this 60, is equal to VRMS squared. Remember, we're keeping this the same, we'll just say it's 120, and this is over 100 watts, right? Versus, what was it, R 100, right? I see what I did there. Making a few mistakes, but we'll get through it. VRMS squared over 60 watts. So I called this R100. I changed this R100 because it's over 100 watts. R60 over 60 watts. Okay, so if we take a look, we want to know which resistance is stronger, right? Well, because these values are the same, these RMS voltage values, we don't really consider those in the in what we're looking at, right? So this is going to be, since this is higher, this value is going to be lower. Since this is lower, this value is going to be higher. So then what that means is that R100, for a 100 watt bulb, the resistance is going to be lower than the R60. Like that. Okay, moving on to problem number 5. We are told a 24 kilo ohm resistor is connected to an AC voltage source, dissipates an average power of 0.6 watts. Then we're asked to calculate the RMS current in the resistor. So we want I RMS. That's part A. And then for part B, we're asked calculate the RMS voltage of the AC source. Then we want V RMS. Okay, so while we know the resistor, we know the resistance, this should be easy to find. So the first thing we need to do, since we know, I didn't write this down very clearly, this is P, right? Since we know P and we know R, and we're asked to find I, we can use the formula that we had before. Power is equal to current squared times resistance. And then we solve for current, like that, right? And then we have 0.6 watts over 24 times 10 to the 3 ohms, all under a square root. This is going to give us 0.005 amps or 5 milliamps. Okay, that was part A. Now for part B, we are asked to find the RMS voltage, right? We can just use Ohm's law in this case. So V is equal to I times R. Recall, V RMS is equal to I RMS times R, which is equal to 5 milliamps times 24 kilo ohms, or to write it out more explicitly, 24 times 10 to the 3 ohms, and that's going to give us a value of 120 volts, which is sounds very reasonable.